Now we already saw that these two graphs, G and H, are in fact isomorphic. We already saw that because it was easy to tell that that our intuition was correct. That if we put H down here, like this, let's see, U2, U3, U1, U4, that there is a one-to-one and onto function from the vertices of G to the vertices of H that preserves edges. But now I'm gonna prove it for sure without just intuition, and this will show you how to do it when you have things that are, when you have two graphs that are lots more vertices, lots more edges, and it's really hard to tell. All right, so we can see that that our function should be something like, or should be exactly U2, U3, U1, U4. Okay, all different, so a function, all different, so one-to-one, no DNEs, so onto. So we have a one-to-one and onto function, F from the vertices of G to the vertices of H. Okay, now we need to check, does this function preserve edges? Okay, so let's first fill out this cell. Let me show you how I would do that. F of Vi, F of Vj. Okay, now the I and the j, that's the 1 and the 2. So you can think of this as 1 and 2. So V1, F of V1 is U2, F of V2 is U3. So that's what goes right there. U2, U3. Now I'll do this next cell. See, we got 2 and 3, so 2 and 3. Let's see. V2 goes to U3. V3 goes to U1. So that's U3, U1. And now the I and the j are 3 and 4. 3 and 4. So V3 goes to U1. And V4 goes to U4. So what goes there is U1, U4. All right, so now we just ask, is U2, U3 an edge in H? Let's see. So I'm looking at this one here, U2, U3, yeah it is. So yes. Is, looking at that one, is U3, U1 an edge in H? Yes. Is U1, U4 an edge in H? Yes. So if we have a function table, this is what I call the function table, that represents a one-to-one and onto function, and we have an edge preservation table with all yeses here, then we can say that F is in fact an isomorphism. So here we see that's true, so F is an isomorphism.